talking about the buffer system, a buffer is a solution that contains conjugate acid-base pair, which minimizes changes in pH. That's the basic definition. But generally, if you remember when we talked about the weak acid, that they dissociate partially to produce an hydrogen ion and a conjugate base. And the presence of both the weak acid and the conjugate base in the solution make up what we call a buffer system. And their function essentially is to minimize the changes in pH. Every time there is a change in pH, maybe there's an excess of hydrogen or excess of alkalinity, there will be a movement either forward or backward depending on the situation, whether the weak acid will go forward to produce more conjugate base and hydrogen ion, or the conjugate base will mop up the excess hydrogen ion in order to reduce the alkalinity or acidity of the body, as the case may be. Now, different types of buffer system are present in the body, and essentially they include the bicarbonate buffer system, the phosphate buffer system, and the ammonia buffer system. It is important to know that buffer is a temporary solution to changes in acidity and alkalinity of the body. They tend to work round the clock every day of our life, whether we are awake or we are sleeping, despite all the physiological activities going on in the body, generating all the excess acid or alkalinity. The function of the buffer is to ensure that those excess hydrogen or those excess alkalinity do not harm us or do not injure us, and they make sure that the pH of the body is returned to normal. So buffer systems tend to generally provide a temporary solution to changes in pH, and it's very important that if there is any excess hydrogen ion, it must be excreted from the body in order to ensure that the person is safe. Having said that, there are different types of buffer system in the body. I need to make it clear that they don't all function equally or in the same capacity to ensure that the pH of the body is maintained at a steady state. Now, the buffering capacity of each of the buffer system will depend on either the concentration of the buffer system and the relationship between the pKa of the buffer and the pH of the solution, meaning that the higher the amount of the buffer system present in the body, then the more likely that the buffer system will be called upon to respond to changes in pH of the body. Also note that every time I talk about solution in this situation or throughout this lecture, I'm referring to the blood, the human blood. So the relationship between the pKa of every buffer system and the pH of blood is also a very important factor that will determine the buffering capacity of that buffer system. I'm going to try to explain that further. Now, these are the three important points I want us to know concerning buffer system. The first one is that a buffer has its maximum buffering capacity when its pKa equals the pH of the solution in which the buffer exists. For example, in the human blood with a pH of 7.4, for example, a buffer that has a pKa that is very close to 7.4 is more likely to function better than a buffer system that has a pKa of 6.1, for example. So if we have the option to choose a particular buffer system in any kind of situation when there are changes in pH, it will be more meaningful or more relevant to choose a buffer system whose pKa is closer to the pH of blood, which is 7.4, than another buffer system whose pH is far from that of blood. The second point to note is that a buffer is more effective in solution with pH within the 2 plus or minus 2 units of its pKa. What that means is that, for example, if you are talking about the human blood with a pH of 7.4, it will be more reasonable to take advantage of a buffer system whose pKa is within plus or minus 2 units of 7.4, meaning that a buffer system which has a pKa of 5.4, between 5.4 and 9.4, will be the best type of buffer system that can work in human blood. It does not necessarily mean that other buffer systems will not work or will not suffice. It only means that the buffer system that has their pKa within plus or minus 2 units of the pH of blood are usually going to be more effective than those other buffer systems. The third bullet point says that buffers work best when the ratio of the weak acid to its conjugate base is within the range of 10:1 to 1:10. What this means is that it's usually very nice to have a weak acid and its conjugate base to be in a very close proportion. Okay, in fact, it is better to have the concentration of a weak acid and its conjugate base to be the same in a solution. But because that does not usually happen most times, it works best for a buffer system when the ratio of the weak acid to the conjugate base is not more than ratio 1 to 10. Again, this does not mean that if the ratio of weak acid to a conjugate base is more than ratio 1 to 10, that the buffer system will not work. It only means that the buffer system will work better. In fact, they will work best if the ratio of the weak acid to its conjugate base is within ratio 10:1.